Hi, good morning. Today let's try to solve one problem. It's a daily Leetcode problem, and I had already solved this problem just now. So I am explaining how to solve this problem. Uh, it's a problem name is missing first missing positive, and it's a hard level. Question is stating that you will have an unsorted integer in the array nums, and you have to return the smallest positive integer if that is not present in the nums is nothing, nums is the array. Okay, so you have to implement an algorithm which runs of big O of n times, and you can use an auxiliary space of O of 1. uh, you'll get a array of nums like this 1 2 0. So what is the next missing number? That is a 3, because 0 1 2 will be there, and then next your positive lowest is after 1 and 2 3 will be there. That's why 3 is coming here. If you see which one is the lowest positive, so before 3 1 is there, so after 1 3 is directly coming, so in between something is missing, so 2 is a missing, so you have to return the 2. If everything is present, then you can directly return nums plus 1. Okay, so my approach will be very simple. I will use a swipe function and iterate the nums nums and then check the indexes, and according to the index it will be swapped. After that, again run the for loop and check the corresponding index and the elements. Okay, and if this condition is satisfied, then we'll return the index plus 1. You will understand this when we run the code, otherwise you directly return n plus 1. Okay, so I'll write a swipe function here. So it will be private, and then I will not return anything. I will just call the method name as swipe, and I will pass 3 arguments, array, and then the one I and another j. Okay, so this is very simple. It's just similar to the how to write the swipe method. You have to use that. Okay, so I'll do this, and then array of I. Here I will give the array of j, and in the array of j position I will put the temp. Okay, in the j position element I'll put the temp. So this will do the swipe. Okay, just let's find out the length. N is equal to nums dot length. Alright, so this will give the length of your array. Iterate the nums. I will start from 0 and it will go till last, and then here is we will increment I plus plus. Now we have to do some condition. Check the indexes and place it accordingly. What accordingly I place the elements. The element must be placed according to the index, and then we can easily find out who is missing. Okay, which element is missing. Okay, so we will just give one condition just to find out if your nums of I is greater than 0 and the nums of I is lower than or equal to the size of the array, that is your n, and another last condition is nums of I should not be equal to the nums of nums I minus 1. So we if we encounter this condition, if this is not or, okay, this is the n, so all these three conditions must be satisfied, then only we will do the swipe. I will call this again and I'll pass the references nums I, and the last one is nums of I minus 1. So this will work for me. So this will rearrange all the things. This will rearrange the indexes and the elements. Okay, so again I'll run a for loop. So this will go till n as usual, and this will go like this. What I will do here, I will just check one condition. This one I'm checking here. Okay. So if nums of your I is not equal to the I plus 1, that is your index, then what I can do, you simply return the I plus 1, because that is the point where it is missing. Okay, this will be the element which is missing. You will get to know when we do this, when we dry run this. I will dry run. And at the last you return the n plus 1. So very straightforward. Let's take this example. Okay, this example as a test case. So in the nums we will have an value like 3, 4, minus 1 and the 1. Okay, so nums will count from the 1. So this, how many elements are there? There is 4 elements, right? So they will directly put as 4. Nums is 4 now. Now we iterated from 3, 4, minus 1 and 1. So the first value is a 0. So at the 0 index, what is this? 0 index we are having 3. Okay, so how to write this? I'll write like this. Okay, so in the nums of 0, what we have 3, right? So this is 0 place. So at the 0 we are having 3. Now we have to check it. We have to find this condition. So just above this I will write this. So is nums of I is what? Nums of I is 3. Is 3 is greater than the 0? Yes, that is correct. If that is correct, then we will come to next. Again, is 3 greater than or equal to n is 4. Again, this is also correct. Now we will come to next. So this is 3. Is it not equal to the nums of nums I plus 1? That is your nums of, what is nums of I? Nums of I is 3, right? No, yeah, nums of I is 3. At 0 is 3. So minus 1, this is what they are saying. So this is equal to nums of 2, right? Yeah, so nums of I, yeah, 3, 2. So what is there at the 2 position? 0, 1, 2. Okay, so at the 2 position it is minus 1. So this is not equal to now. So 3 is not equal to 2 minus 1. So we will order this swipe method. Call this swipe. So if we call this will do this operation. So minus 1 will come here, 4 will remain as it is, and 3 will come here, and the 1 will come at the last. Okay, so this will continue, this whole thing will be continue, and then finally we will get a value like this. Wait, did I notice any? Yeah, so at the end we will get a value. what we'll get 1, okay, 3, 4 minus 1, we'll get like this. Okay, so now coming here to the point, so in the 0 we are having this 1, right? So in nums of I means 1 is not equal to I is what? I 0. So 0 plus 1 is 1. No, this is not true. So your I value will be again incremented to 1. At the nums of 1, what is this? At the nums of 1 we have 3. This 3 value is not equal to what is your I is now 1, right? So 1 plus 1, so I is 2. So this means 2, right? So 3 is not equal to 2. This is correct. Okay, this is correct. So we will return I plus 1, that is your 2. You will return the 2. Okay, you return the 2. Suppose why we are doing this is because, see, you have 1 2 3 4 5, you have this like this, your test cases is like this. So is there any lowest positive integer? No, right? Not possible. So you'll simply return the n plus 1 means for this n is 1 2 3 4 5, size is 5. So you, when we return n plus 1, it will return 6, because your n is 5 plus 1, so 6 will be returned. So that's why I'm returning this. Let's run this. Submitted. Yes. Okay. We base 98.00 and the runtime is 1 millisecond. Micro milli, I don't know. So time complexity, we use one for loop here. This was just checking, so this will not be counted. So here O of n, here is O of n. So this O of n is independent. Again, this O of n is again independent. So we'll take the time complexity as O of n. Okay, and the space complexity, we are taking one auxiliary, so it will be considered as big O of 1 a constant. Okay, temporary we are using here. That's why. Okay. Thank you guys for watching the video. If you have any doubts, put comment on the YouTube.